This is a video lesson for Module 3, Lesson 5. The Lesson 5 learning target is I can multiply multiples of 10, 100, and 1000 by single digits, recognizing patterns. So we're going to be building off of our work in Lesson 4, where we were just multiplying by 10, 100, and 1000, and we're going to be using multiples of 10, 100, and 1000 to multiply by single digits. So let's go ahead and jump into a few problems here where we can really see the pattern of the strategy we use to solve these types of problems. So I'm going to be solving a series of problems here. I'm going to start with the first one up here, 2 times 4. Then I'm going to be solving 2 times 10. Then 2 times 40. Then 2 times 400, and then 2 times 4,000. I'm going to be using place value disks on a place value chart, and I'm also going to be showing off to the side over here how you could do it numerically as well. So for 2 times 4, the first thing I'm going to do is I'm going to represent this first number 2 in the place value chart. So it's 2 ones. And when I multiply by 4, I just make 4 copies of it. So I have 1 copy, 2 copies, 3 copies, 4 copies. And I count out my total. I have 8 in the ones place, so I would say 2 times 4 is equal to 8. So pretty basic fact there, but you can see we get this idea of copying these 2 ones 4 times to get to 8 ones. 2 times 40, we're going to do a similar process here. Once again, I'm going to represent 2 in the ones place here. And I'm going to start by first thinking about 40. Draw my little thought bubble here. I'm going to decompose it into 4 times 10. So the first thing I'm going to do is I'm going to multiply the 2 ones by 4. So make 4 copies just like above. So I've done this part. And now I'm going to multiply it by 10, which is similar to what we did yesterday. I'm going to take all of these ones right here, and I'm going to shift them over one place value into the tens place. So all those ones just became tens. So now I have 8 tens, and there's 0 ones left over. And to show that numerically, what I just did is I took 2 times 40. I decomposed 40 into 4 times 10. And then I did 2 times 4 first, which gave me 8. And then I multiplied 8 times 10, which gave me 80. So we can do a similar thing with the third problem here, 2 times 400. Once again, I'm going to start with my first factor, 2, represented as 2 ones on the place value chart. And then when I look at my second factor, 400, I'm going to think and I'm going to decompose it into 4 times 100. Because 4 times 100 equals 400. And then I'm going to go step by step. I'm first going to do 4 groups of the 2 ones. So I'm going to multiply the 2 ones by 4. So now I have 8 ones. You might notice a pattern that it's the same right here and the same up here. And then I'm going to multiply by 100, which we know from yesterday's lesson means we're going to be shifting over 2 place values. So these 8 ones become 800s. So when I multiply by 100, I get to 8 in the hundreds place. I have 0 tens now and 0 ones. So showing numerically, 2 times 400, I decompose 400 into 4 times 100. And I'm still multiplying by 2. Then I'm going to do 2 times 4 first, which was 8. And then I'm going to multiply by 100, which equals 800. So hopefully now you're starting to see the pattern here where we're doing the first step first. We're multiplying 2 by 4 after we decompose and then multiplying by whatever the second factor is. So let's move on to 2 times 4,000 here. Same process. I'm going to start with 2 in the ones place. I'm going to have to decompose my 4,000 into 4 times 1,000. The first step, I'm going to make 4 copies of the 2 ones, multiplying 2 times 4. That gives me 8 ones. So check. And then I'm going to take these 8 ones and I'm going to multiply it by 1,000, which means I'm going to be shifting over 1, 2, 3 place values. Check. So now I have 8 in the thousands place, 0 hundreds, 0 tens, and these ones got moved over, so I have 0 ones as well. So I get an answer of 8,000. So just to show numerically, 2 times 4,000. I'm going to decompose 4,000 into 4 times 1,000. I'm still multiplying by 2. Then I'm going to start just like before with 2 times 4, which is 8. And then 8 times 1,000 is equal to 8,000. So a few things to be paying attention to. In each problem, we started with 2 times 4, when we didn't need to decompose, we would start with 2 times 4. In the problems where we had to do a decomposition, we started by decomposing. So we decomposed the multiple of the 10, 100, or 1,000. But after we decomposed, each problem started with 2 times 4, and then we multiplied by 10, 100, or 1,000. So you can see now how we can solve these types of problems, both with a place value chart and numerically. So let's take a couple more examples here and see if we can solve these two problems numerically using the same process that we just did above. So 20 times 7, I have my multiple of 10 as the first factor and then my single digit as the second factor. So I'm going to decompose 20. Think about it's a multiple of 10 and it's 2 times 10. And I'm still multiplying by 7, so I'm just rewriting the problem as 2 times 10 times 7. Now, since the 2 and the 7, our single digits, are not next to each other, I'm going to use the commutative property of multiplication, which states that I can rearrange all the numbers in a multiplication problem and have it equal the same thing. So I'm going to put the 2 and the 7 next to each other. Now I'm going to multiply 2 times 7, which is 14. And I'm still going to multiply by 10. So now, using my 10 strategy from yesterday's lesson, I know that 14 times 10 is going to equal 140. Same process for up above. We have one factor of 5 and another factor of 400. I'm going to decompose 400 into 4 times 100, and I'm still multiplying by 5. So now I can solve 5 times 4, which is 20. I'm still multiplying by 100. And I know that 20 times 100 is going to equal 2,000 because I'm shifting the 2 and the 0 over two place values. So that just about does it for lesson 5. You should feel pretty confident now in solving multiplication problems that have multiples of 10, 100, and 1,000. And you should be able to answer all the questions in the lesson 5 problem set. But as always, if you get stuck or need a refresher, please feel free to come back and rewatch any part of the video to get yourself a little bit of help. So good luck with the problem set, and thanks for watching.